Kudamula. I'm one of the third-year fellows in the neonatology at the Met. I also work here in the NICU too. So today I'm going to talk about surfactant and some facts about surfactant. And so in this talk, like I'll talk what's a surfactant, I'll talk about what's premature lungs, how the surfactant helps the premature lungs, and indications, contraindications, different types of surfactant, how they administer the surfactant, and complications. So I have no data like how often on the field when PD flight go outside give pure surf or the surfactant.
Not very often. Not very
It's
often.
not often.
Not very often. Yeah, but a situation might arise that you go to an outside hospital where to pick up a premature baby, and at that facility there's no sufficient help giving cursorf. I think PD-Flight team should know how to administer cursorf. It's very easy and it's life-saving. So what's the lung surfactant? It's a substance produced in the lungs to reduce the surface tension in the alveoli and small airways, and produced by type 2 cells in the alveoli, and it's made up of 80% of phospholipids and 10% protein and 10% of neutral lipids, and it prevents the alveoli from collapsing. That's the main use of surfactant. And we are dealing with premature lungs here, which are incapable of producing adequate surfactant. I'll show you when the surfactant start to produce and at what maturity level. So here I put this picture to show the alveoli and its relation to the blood vessels. And the blue part is the alveoli. Alveolus has it labeled, and there are some type 1 cells which coat which line the alveolus, and there's a type 2 cell in the middle, yellow, and this is the one produces surfactant, which pours the surfactant into the alveolus like that, and prevents the alveolus from collapsing. That's the main use of it. And this surfactant is produced, course the alveolus, and it recycles. So it's a complex process, and it's not to the maturity level in a premature baby. And also we should note how close this alveolus is to the blood vessels. This is the artery, and that's the vein, blue color. So it's very important because the lining of the alveolus is very, very thin in premature babies, and the mechanical ventilation we give should be adequate, not excess, just adequate to protect that thin layer. Otherwise, any disruption to it will have a blood leaking to the alveolus, and that's dangerous. So here I put this diagram showing like different stages of lung maturity. So in 7 to 16 weeks of gestation in utero, we have a pseudoglandular period where like the respiratory bud is just into the mesenchyme, and it just forms a pseudoglandular like thing. And in canalicular period, which is 16 to 26 weeks, it starts to form the canal-like structures. And cycler period is 26 to 36 weeks. and alveolar here is 36 to 41 beats. And in the books, they say that in a term baby, we'll have at least like 300 million alveolars, and in a premature baby, we'll have like 30 million. So there's like tenfold low number of alveolars. So I put the green star because that's where we deliver some premature babies. So we can imagine like how much difference is there and what kind of alveoli we are dealing with. So in this picture, I put this, it has the same kind of status, but it shows the surfactant. So it starts to produce, the lungs start to produce at around like 24 to 25 weeks. Let's say like if we deliver a baby at 23 weeks, we barely have any surfactant. So the peak amount of surfactant is produced at birth by 38 weeks, and it still like goes on producing. But before 38 weeks, we still have some deficiency of surfactant, which we need to supplement for adequate lung opening. So I put this pictures to show how the lung look like. You know, on your left, it is a lung in the histopathology, and this is electron micrograph. So notice like how alveoli are open and stiff, uncollapsed alveoli. This is a normal lung. And this is a surfactant deficient lung, which has very thin alveolar lining and different sizes of alveoli. Because since these are since these alveoli doesn't have surfactant, and they tend to collapse into adjacent alveoli. So the smaller ones emptying with the larger ones. That's why you have like different shapes of alveoli. So what surfactant does? So it opens up the collapsed alveoli and keep them open. That's why you can see the picture on the left has there's a before surfactant, and this is after surfactant, which you can notice some of the collapsed alveoli before were open. So when we go out, like we'll have some X-rays presented to us. Baby might be intubated, might not. We might have to intubate the kid there. And the X-ray on the left is a very early picture of a premature baby, which shows like diffuse reticulogranular appearance, and the heart borders were not well defined. You can see the 8 bronchograms. That's the typical picture of the HMD or hyaline membrane disease. We call it as radiologists call it as like surfactant deficient lungs. Once we give the surfactant, the alveoli are all open, and we see good aeration. We can see the hard borders. That's the effect of the surfactant on the lungs.